storm, after the storm, people, how they survived. When we were standing there, one of the stories that I heard that was just truly amazing was a family. Yeah, the family was inside the home. The hurricane and
the apartment window. The Pay and Save Annex building, like many Lihue businesses, was brutalized by the storm. The roof of the ILWU building on Rice Street was also a casualty. No part of the island was spared by the destructive force of the wind gusts of 165 miles per hour. Here on the south side, the popular Brennike's Beach was pummeled by...
Oh my God, his whole section of the roof just blew off. What? I mean, like a whole 10 feet.
Oh man!
Bill Ballard took this dramatic footage of his neighbor's house in Omao.
Right there, yeah. There it goes, right now, folks.
Oh my God!
Neighbor's roof is now blowing off their house.
As the storm built to a peak, we took a drive in hurricane-force winds. Right in front of us, there's one that's about to go.
I feel stupid asking you, but what's the whole premise of this project, of this research?
The premise of the project is to get better information about the types of extreme winds that are at the ground level where the homes exist, rather than in the upper atmosphere, which is where the hurricane hunters tend to give us their wind speeds. That's where they're measuring. So we want to find out, when they say it's 130 miles an hour, what does that really mean down where the houses are?
And what do you hope to glean from this? Where houses are weak, what we can do to better combat this?
There are several different things going on in the measurement systems. One part of the measurement system is to measure the wind speeds themselves. Another part of the measurement system is to measure the resulting forces, pressures on typical residential one-story houses in Florida. And the idea is to get better information for future design work and also retrofits for existing homes. So we can say, look, based on the data we've collected, this is the kind of damage that occurred in these locations, and these were the forces we measured. So if we do the following things, it should be sufficient to take care of those problems. So we're trying to avoid over-designing, spending too much money, but also provide adequate protection for homeowners.
This hasn't been done before, at least not on this kind of a scale.
Not on this kind of a scale. It has been. There have been full-scale home instrumentation projects in place by several other universities, and they're doing good work as well. This is the first one that attempted to instrument multiple homes, specifically in hurricane-prone coastal regions that are portable systems.
And tell me how it works. When a hurricane's threatening, you guys run like Irene. That's a good example.
Yeah, there are two different, basically, go strategies. One is if the hurricane path is predicted to hit the southeast coast of Florida, that's the region we have these 10 homes spread out about 10 miles apart. And so the go strategy is to go down there to the homes, put the instruments on the homes, get the wiring set up, run the computers, do the diagnostics, and then go to the second part of the go strategy, which is to find places to put the mobile wind speed measurement towers. Now, if a hurricane is coming into, let's say, the Tampa area, we don't have any homes instrumented there yet, but we can still go and bring our portable towers to measure the wind speeds.
And that's what you did in Irene, right?
We did that in Irene, right.
And you, where in the homes? They're in the Fort Lauderdale area, is that right?
The homes are stretched from as far north as Jupiter, Florida, down to Homestead, Florida.
Okay. And don't you have some in the Panhandle too, or is that where
we do? We're identifying appropriate homes in the Panhandle now, and so that's going to be hopefully part of this season's project is to instrument 10 more homes.
And these are volunteers, people who, do you pay them a nominal fee? How do, these are regular homes, right?
These are regular, yeah, lived-in residential homes. The owners have agreed to allow us to do this under several conditions. One is we provide them with some hurricane-resistant retrofits for the homes, for example, hurricane shutters and some other measures. And in return for that, they allow us to come and put unobtrusive instrumentation on their homes. So on a typical day, you don't even know that it's there. The only time you see the actual instruments is when the hurricane's coming.
Now, what did you learn from Irene?
Irene specifically, we got some fairly good data from the wind speed measurement towers. Since it's a very localized instrumentation package, we're not using satellites or anything like that, so we knew what the maximum wind speeds were along the barrier island of Melbourne Beach. And that's the kind of information we set up 4 different towers in that region, progressively inland along the same horizontal path. What that provides me as an engineer is information not only on what the maximum wind speed was, but how well was the wind speed at the shoreline correlated with a mile back and 2 miles back and 3 miles back, so that in the future we can develop models from this data and say wind speeds were 130 miles an hour up here, that means they're 110 up here, that means if you're 3 miles inland it should be about X.
And what'd you find?
Essentially right now we're still in the data collection stage of the project, and also the instrumentation project validation stage, making sure everything's working sufficiently. We do have some numbers as far as maximum wind speeds for the specific location we were in. They were upwards of 80 mile an hour, 3-second sustained gusts for Hurricane Irene.
And that was on the outer island. What about 1-2 miles? Was there significant differences?
We had the maximum open exposure there, so we expected and did in fact get the highest sustained gusts there. Further inland, they progressively went lower as we got further inland, which is what we expect.
Would expect.
Right. But before we can develop models and draw conclusions, we need to do this a number of times over a number of storms, a number of locations. We can't very well say we took this one storm, took this location, this one spot, now everybody's got to make changes based on what we found.
And that's my next question. What kind of life of this research? What are we going to look at? You want to do it over a 10-year period, 5-year period? I mean, what's your model here?
Well, it's hopefully intended to be a continually growing project. I mean, the initiators of the project were Clemson University with the Florida Department of Community Affairs sponsoring the project, and they brought University of Florida on board last season, and also Florida International. And what we're looking to do is continue to expand the amount of instrumentation that we have and the number of homes that are instrumented. And the more physical setups we have, the more universities and more research involvement we're going to need. So to answer your question,
it's open-ended.
It's open-ended. The more data we can collect, the better. Absolutely. There is we're done after 10 years. If the project flourishes and we're getting good information, I see no reason why not to set up, perhaps go to permanent wind stations throughout the coastal regions.
Okay, then let's back up. How long do you, as a scientist, you got to have some kind of, well, like you say, one hurricane, and Irene really was that, just brushed us. You know, what do you feel? When would you feel comfortable being able to say, as a model, here's what we can expect?
I think what we're looking for is an event where we're able to capture a fairly significant storm, Category 2, Category 3, where we're able to get at least eye wall characteristics on both the homes and the wind speed measurement towers. And from that kind of information, that's really the upper echelon, the upper limit of what we're looking for. We're looking at what are the maximum likely forces that these homes are going to be experiencing. And so it's hard to draw conclusions until we capture one of those events. So it's an open-ended answer. If it happens in 2 years or 3 years or 5 years, it just depends on what Mother Nature throws at us.
Perfect. Perfect.
You're good. Go ahead. Okay, stay right.
Okay.
Okay, do that one more time for me. I know this is going to be odd, but come back to your book again. And instead of going to your mouse, go to your keypad, like you're going to type.
Okay.
Perfect.
Does it matter that nothing's on the screen of any
Doesn't matter.
I rarely found those keys. I want to use a tight shot of the keys into one.
Hey, Steven?
What? Shut up.
Okay.
Keep typing.
Oops.
Okay. Good. I hit the keypad a couple more times. Okay, now I'm actually shooting your screen so you can show me some things there if you want to tell me about what we're seeing. Or...
Okay. Well, this is part of a presentation that we gave at the National Hurricane Conference this year in New Orleans. So this part of the presentation picks up where we're discussing what exactly we did for this previous season. So this is a view of the 4 portable wind measurement towers that were built at Clemson University. And these fold up into 10-meter towers. We'll see a picture of that.
Okay, you can go ahead and go into another one.
Okay. So just in order of their occurrence, this is Hurricane Dennis, which didn't quite hit the coast until it turned tropical storm. And it's a picture of one of the towers that we deployed in the Wilmington area. Hurricane Floyd, we set up about Jupiter, Florida or so. And this is our first chance to actually test the house instrumentation system in addition to the towers. So we met, the 2 university teams met at Jupiter, Florida, and put the sensors on the buildings and went out to find some spots to put the towers. And since Floyd took that turn up north, we didn't really get too much interesting information from the houses. But we did validate that the data collection system was working, which is a big achievement for this season. In Hurricane Irene, we captured the most interesting data for this season. We set up in Melbourne Beach. As you can see here, we're on a parking lot on a barrier island. The parking lot was paved the night before. This is the day after, and it's covered with about 2 inches of sand now from the winds. It's a tower system we have set up, and we're in the process of collecting the data and then taking the thing down. And it collected data up here and down here, what I'll show next is some of the data from that top set of anemometers. What I have is a picture of the most severe time in the storm from where we were located. That blue line represents the maximum instantaneous wind speed that was being recorded at 50 hertz, or 50 samples per second. A common engineering statistical measurement is the average 3-second gust, which is to take as many measurements as it take over 3 seconds and average them together for a sustained gust average. That's the green line there. So an engineer would be more interested in finding the maximum 3-second gust. And down here is a 2-minute gust, just for comparison to show what averaging does. All right. And then this is just another way of looking at that same piece of data, looking at a much more detailed time history. This is the full sampling at 50 hertz over 350 seconds, just as a little piece of what we do for the data analysis. And some towers we'd set up at also